Hello, class. It's just me, Mr. Wee. I'm going to be going over some things from 1.4. So let's kind of continue where we left off of class on this recent Thursday. So we left off with these situations. Oh, let me kind of open this up here. With these questions that were basically multiplying specifically binomials. But you might have noticed a trend that most of these guys, so you can take a minute to pause this and kind of recollect your thoughts, and these are the solutions that you should have ended up with. But if you think about it, it's fairly interesting what you might see. So let me kind of get my things in order here. I know what I'm going to say specifically. Okay, so if you look at what you got, you have a situation where each of these binomials are being multiplied. They look exactly the same, except that they only differ by one thing, the sign in between. And as a result, what happens is you're always going to have this weird situation where you multiply them, you multiply out the binomials. You'll have a situation where you have two guys at the very ends. Like the first thing that you might do is x times x squared here, and then x times negative 3x or negative 3 here. Then you should get, sorry, so I might have ran this a little bit out of order. That's minus 3x, and this is plus 3x. So what you're going to see is this here and here is going to be x squared minus 3x. And then you're going to have to multiply this second guy to both those numbers in here. So you're going to have minus or plus 3 times x here, plus 3x, and then plus 3 times minus 3. You're going to have a situation where the two x values, or the two values that have only an first degree x value, always cancel out when you have a scenario where the binomials you're multiplying by are exactly the same. It only differs by one, by the sign. So what you end up having is a situation where essentially all you do is you multiply the first guys, x and x, and then you multiply the second digits together, 3 and negative 3. That will give me 9. Because if I do that for every situation, you're going to notice that always happens. You're always going to have a situation where it's just the very first two guys that you multiply, and then the very last two guys you multiply. 2 and negative 2, and x and x. You end up having x squared minus 4. This is 2x and 2x, and we're multiplied together to give you 4x squared, and then positive 1 and minus 1 will give you negative 1. So, and then that happens again here. So that always will happen. What is this situation called? So I'm going to kind of write down 1-4, section 1-4. This is called special products. Oops, sorry. Let me kind of back this up here. So this section is called special products. So here's what I'm going to do. I'm going to have a video for each section. Or at least this is going to be 1-4, this 1-4 and 1-5. The next part 3, is going to be 1-6, and maybe I could do 1-7 in that one. But at the very least, we're going to have at least 2 more videos. Okay, this one, including this one, and then the next one probably. Okay, so special products. The first thing that you're going to learn is it's called the sum, the product. I'm sorry, it's the product. The product of a sum and a difference. And a difference. And you just saw what that looks like. You just didn't know what it was called. Well, we calculated the products of many sums and differences. Here is an example that still works. 2x squared plus 3 times 2x squared minus 3. This is the sum, and then this is the difference. And then we're multiplying them together. So here, I mean, I'll work it out, but essentially your answer in theory should just be these first two times these last two. So it should be 4x cubed. So it's going to be these two. 2x squared times 2x squared is going to be 4x, not cubed, but to the 4th power. And then it's going to be the last one here. And then if you don't believe me, let's go ahead and work this out really quick. I'll color code it. The 2x squared goes to both of these guys. So that's going to be 2x squared times 2x squared is 4x to the 4th power. 2x squared times minus 3 is going to be negative 6. I'm sorry, negative 6x squared. And then in green, we're going to take the second number in this parentheses and multiply it to both those numbers. So that's going to be 3 times 2x squared. So that's going to be plus 6x squared. And then positive 3 times minus 3 is going to be minus 9. And if you can see here, when we combine like terms, this is a minus 6x squared. This is a plus 6x squared. See? So you do end up with this situation. So how do we formalize this? Well, typically what we're doing is we're taking an a plus b. So I'm going to write in more general terms, meaning that this represents pretty much any numbers, any random numbers, in that if you have a number that is, like, let's just say a, and it repeats itself in here, and then b, it repeats itself in both of these binomials, but the only difference is one's being added, one's being subtracted, and you multiply them. This is the sum, and this is the difference. You're always going to have a situation where you have a squared minus b squared. Always. So in this case here, let's go back up here. This is our a, and this is our a. A squared should be 4x to the fourth power, and then b is, your b is 3 and 3, but one is being added, one is being subtracted. So you're going to have a situation where b squared, which is 3 times 3 is 9, is being subtracted. Okay, so this is the general formula. You can put a square around that. Okay, so that's it for that. You can try one right here. You can try a little sample problem. It's going to be 3n plus 2 times 3n minus 2. You can pause this right now and then work on this, and I'm going to put up the key in just a second. Here's what the answer should be. It's 9x squared minus 4. So you can double check your answer if you don't believe me, okay? All right, let's go ahead and move on to 1-5. So this video will be on 1-4 and 1-5. So this is 1-5. So that's 1-4. That was pretty much the biggest thing that I wanted you to learn. So from 1-5, you're going to learn factoring by grouping. And here's an example of what that might look like. You have 4QR plus 8R. This already looks really complicated. Plus 3Q plus 6. So here we want to factor this out. Meaning I gave you a polynomial, right? And I want you to go back into a situation where, can you write it into binomials, or like b plus r times r plus q or something like that? Can you write this back factored into a binomial times a binomial situation? You don't have to write that down. I'm just saying that's what we're going to end up kind of doing, okay? So actually, I think this is this section, I apologize, is factoring by using the distributive property. Using the distributive property, that's what the section's called. And then this specific type of problem I'm about to use is factoring by grouping. So here's what you're going to do. You're going to group any guys that have a similar letter, like R and R. I know this has a Q here, but I could already kind of see how this aligns. So what I want to do is I want to group two numbers together that are very alike, and you can kind of see that they have similar factors. And I want to do it 2 times in these 4-term polynomials. These two, I noticed, have a similar factor of 3. These two, the reason why I didn't pick this Q and this Q, like this guy that has Q and this guy has Q, and group them together, is because I noticed that 4 and 8R, 4QR and 8R both have a common factor between 4 and 8, and they both actually have R as well. So these make for a better group. And what I can do is I could factor out both R. I can factor out R. So what I mean by factoring out is I'm going to take out R out of both of these guys, the 4QR and the 8R, and take them out. And right now I'm left with 4Q plus, let's see, 8. Now it's just 8. But I also realize that I can also factor out, instead of just R, the number 4. If I factor out 4 from 4Q and 8, it's going to come out to be 4R times just 1Q plus 2. That's a lot, and that's what I want, okay? You're going to kind of see how this kind of works out together. It's just actually really nice. The second step over here is, what factor can I come out here, or can I grab out of 3Q and 6? There's no letters, so I can't grab out Q out of both of them, but I'm going to grab out a 3. So I am left with Q plus 2, because factoring out 3Q by 3 is going to give me just a single Q, and factoring out 3 out of 6 is going to be a 2, okay? And what do you guys notice? Let's rewrite this one more time on the second line. What do you guys notice? Well, both of these groups that I grouped together have a similar factor of q plus 2. So it's like it's like saying 4 times 2 plus 1 times 2. Okay. Or actually, let me show you what's going to happen here. Since these both have the similar factors, I'm going to combine these guys into their own group. 4 plus 3 times q plus 2. Okay, and that's going to be your final answer. We factored out this large polynomial, 1, 2, 3, 4 terms, and we factored it into 2 binomials. That was the goal. So it's this, however, this step was a little bit confusing to some people. It's like saying 4 times 2 plus 1 plus 2. It's like saying this. Since they both have a similar factor, I could add these two, 4 times 1 times 2. And then this should be 5 times 2 equals 10. I know you would never figure out a problem like this, but if you think about it, this is 8 and this is 2, and this is equal to 10. Okay, so this is number 5 for this. Or I'm sorry, this was section 1-5 here. And let's see if I can come up with another type of problem or another sample problem. Okay, this is going to be 9fg. You can try this one. This one's going to be a little bit trickier. 9fg plus 45f minus 7g plus 35. Okay, so let's do factor by grouping for this. You can pause it and try it out. But if you don't know, you can just follow along with what I'm doing here. I'm going to group these guys in such a way where I could factor out, like I'm going to group them by groups of 2. And I know that the way I wrote it might kind of give it away already. I can mix up the numbers if I wanted to and try to group them a little bit, but I want to do it in a way where it looks a little bit more obvious. Okay, but I'm going to try to factor out, or I'm going to try to group up numbers that I know I could get a similar factor out of both the numbers. I see this minus 7g and 35, even though they don't share the letter g. I know that they both have a factor of 7, and then over here and here is 9fg and 45. I could factor out an f out of both of these, and I could factor out a 9 out of both of these as well. So that's why this makes this a superb group to group, or a superb set of numbers to group. Some people might say 45 and 35 because they're both divisible by 5, but the 45f is a better partner with the 9fg because 9fg has f and a factor of 9 I can grab out of both of these. Okay, so what I mean by that is if I group these together, I can factor out the 9 and the f. So 9f will leave me with g plus 5. Does that make sense? Meaning that if I factored out, I divided both of these numbers by 9f, I'd be only left with 1g, and I'd be left with a 5 over here. And then here, adversely, I can factor out 7 out of both of these numbers. And let's keep this as a minus, or actually, no, let's not do that. Or actually, yeah, go ahead. Sorry, it's a little bit annoying what I did. Let's factor out 7 out of both of these numbers, just 7. And then I know that if I factor out a positive, I know this is minus 7g, so let's just keep this whole thing minus this 7 times this whole thing, okay? So if I factor out 7 out of g, it'd be g. And I factor out 7 out of 35, that would be 5. Now, I know that looks weird, but if you think about it, let me see. No, actually, I'm still wrong. This is g minus 5, because in order to go, so if I don't know what I did was correct, I just kind of went by feel there, I would go back and see if I can distribute this negative 7 to both of these numbers. This is minus 7g, negative 7 times negative 5 is 35. This looks exactly like the top part here. So that means I did factor this correctly, okay? Let's see. Oh, guys, I messed up somewhere. I'm sorry. The original problem was not written this way. It was 9fg minus 45. So this should have been g minus 5. The reason why I say that is because it wasn't going to work out the way I had it, but That's because I was kind of freaking out when I was taping this. I was like, wait a minute, what's going on here? The reason why is because I wrote this wrong. It should have been 9FG minus 45F minus 7G plus 35. And I think some of you guys might have kind of seen where I was kind of going with this. But they both, because both of these groups of numbers share a common factor, G minus 5. So that's G minus 5. And then 9F and minus 7 are going to be factors outside that you can combine. And there you have it. That is the final answer. 9F7 minus or times G minus 5. That is your final answer. Okay, guys, I'm going to stop right here, and I'm going to come on to a part 3 after this, okay? So you guys, thank you for watching, and you guys take care. Bye.